Hello, everybody. Thank you for joining us. Welcome to this webinar. My name is Jack Henriquez. I work as a product manager for Altium, and I'm joined tonight by David Haboud and Nikolai Nurkov, who are helping me answer questions on the chat. The topic of this webinar is CoDesigner, and in particular the MCAD component placement functionality within CoDesigner. So I'm going to get straight into the presentation. The first thing I'd just like to talk about is go through a typical PCB design flow process, and then explain how CoDesigner fits into this process. Obviously, start with the schematic generation, creation, move through the usual sort of route for developing the design of the PCB, finishing in something that's actually manufacturable. Now, the two particular stages of this process where mechanical input is likely to be required is obviously the board shape definition, and it may well be the component placement as well. So what CoDesigner does is it ties these processes together and allows the mechanical and electrical engineers to work together to develop the board shape, place the components, and I've also included PCB file creation in the scope of CoDesigner because it actually allows the mechanical engineer to initiate a board design from within their MCAD package. Typical input data required by the PCB designer, obviously schematics, bill of materials, any technological requirements, materials, manufacturing capabilities, which obviously have an influence on the design rules used to develop a board. The physical maximum size constraints of the board, assuming it's fitting in some sort of enclosure. The positions of mounting holes and mechanical and electromechanical components and keep out areas. Now, the ones that I've highlighted in bold are the ones where there's likely to be a mechanical input. This webinar is focusing particularly on the component positions. We have other webinars looking at the other aspects of it, one in particular next week looking at the definition of the board shape and the position of the mounting holes. So examples of mechanically significant components might be connectors, buttons, LEDs, and standoffs, and perhaps the mechanical engineer has an influence over both the selection of the component and the positioning of that component on the board. Traditionally, the flow of information between the electrical and mechanical domains typically relies on 2D drawings, DXFs, PDFs, etc., 3D models, which you'll be familiar with, and obviously other sort of communication that's not based on any sort of file transfer. So conversations, emails, hand sketches. Obviously, all of these methods of communication have problems. You get duplication of effort. You get one engineer making changes in their software package. They then need to communicate those changes to their colleague, and the colleagues need to then replicate those changes in their own software. There's potential for ambiguity. You're going to have potential confusions, particularly with 2D drawings and symmetrical boards, which creates a potential for errors and inefficiencies due to time spent reworking mistakes and clarifying communications. So what can we do about this? Well, CoDesigner alleviates these issues by allowing the direct transfer of information from the native ECAD package, Altium Designer, to the native MCAD package. CoDesigner lives as an extension in Altium and as a plugin in the MCAD package. And via Altium 365, the design data is sent backwards and forwards between the two without the need for any manual file transfers or emails or anything like that. So what do you need to be able to use CoDesigner? Well, Altium Designer, obviously, and an Altium 365 standard subscription, which is included with all Altium subscriptions, or Concord Pro. And you need a supported MCAD package. The currently supported packages are Inventor, SolidWorks, and Creo. And I think at this point, we've got a poll question, which David is going to pop up on your screens now. So if you'd be kind enough to take a moment just to fill that in, then that would be very helpful for us. And meanwhile, I'm going to move on to a demonstration of the functionality that I've just been talking about. Okay, we're now in Creo looking at an assembly which contains an enclosure and the CoDesigner board. Now you'll see that the CoDesigner board is itself an assembly. That's because it consists of a board part and all the components. At the moment, obviously, there are no components on the board, so the only the board part is the only part in the assembly. I'm just quickly going to show you this board was created from scratch in Creo. It doesn't exist in Altium yet. It only exists in Creo. I'm just going to show you that board is, if I go into the board definition, you can see that the board is created, we've created it in the context of the top level assembly, referencing the enclosure. See its dimension to the features of the enclosure. And these holes in the board you can see are actually referenced to the holes in the enclosure. I'm not going to go into any more detail about the creation of a board in Creo and the definition of the outline and the hole positions and sizes, because that is going to be the topic of another webinar next month. So hopefully you will all tune into that as well. Right, what we're going to do now is we need to push this board to Altium using the CoDesigner panel that we have here. Now at the moment, because we are still in the context of the top level assembly, this panel isn't active. But if I open up the board assembly on its own, there it is here, we can see the CoDesigner panel is now active. And if I click push, I can then push that through CoDesigner to Altium Designer. So what I'm going to do is attach a comment to that, as you can do with all the every time you push some changes through CoDesigner, you can attach comments to let your colleague know what it is that you've actually done to the board. So we're going to say created in Creo. Click post. This we get this error message popping up at the moment. We can ignore this. It's just to do with some functionality that's being implemented at the moment on the server side, and it doesn't affect any of the functionality. Okay, so now we'll switch to Altium. What we've got open here in Altium is the same Altium 365 managed project that we used to create the board in Creo. At the moment, all we've got is this schematic with a component on it in the Altium project. We don't yet have a board in Altium, so we're going to add a new board to the project. And you see, as soon as we do that, the CoDesigner panel becomes active, and we can see in that panel the board that we've created in Creo with the comment we typed in Creo. If I click View Changes, it tells us the board outline has been defined, and we can preview that shape there, and we can also preview the 4 holes. So let's apply those changes to our new board, and there it is. And we can see if we click on one of the holes, they are actually proper pad holes. They're not just cutouts in the board. So what we're going to do now is define our layer stack. The board at the moment just has the in Creo, it just has the default sort of arbitrary thickness that is defined when you initially create the board, but we need to define the proper thickness in the normal way in Altium Designer. So we'll say 120 mils. Close that, save that. That has now updated the board thickness in the usual way. What we're going to do now is, let me just save the PCB, go to the schematic, and we're going to use the normal ECO method to place the component on the board. What we're going to do is we're not going to worry too much about the location. We're going to put it roughly where we want it, and we're going to allow our mechanical colleague to define the proper position. What I want to just show you at this point is, if we go into the parameters for this component, we can see a parameter called MCAD model name. Now what that does, I will explain that by going into these are the admin settings for the Altium 365 workspace, and in the CoDesigner section, this option here, use models from data management system on MCAD side when creating PCB assembly. What that does is, if we include a parameter in the default name is MCAD model name, if we include that parameter in our Altium definition, our Altium component definition, when this component is pushed to Creo with CoDesigner, CoDesigner will actually look at the value of that parameter, in this case DisplayPort, and it will search the MCAD database or the MCAD file repository for a native MCAD part by using the value of this parameter. Okay, so we've got the part roughly where we want it. We're going to go back to the CoDesigner panel, and we're going to push these changes back to Creo. So we're going to say defined layer stack and placed J1. Please finalize position. Post that back. And we can see there the push and the comment appears in the activity history. So that's gone through successfully. So I go back to Creo now, and there we can see the changes I've just made in Altium that have appeared in the CoDesigner panel in Creo. So let's have a look at the changes included in this push. So we click View, and we can see the board outline thickness has changed, and we can see J1 has been added. So let's click Apply, and we'll see those changes made to the board. You can see over here in the model tree, the board assembly now includes this part, which has the name DisplayPort, which is the value that the MCAD model name parameter was set to, and we can see it's J1 here. There's a slight bug with the regeneration of holes, but that's easily fixed. We just need to quickly go to the top level assembly and activate the board part and go into the hole definition, and then click OK, and that fixes that. we'll get that resolved. Okay, so here's our board with our J1 positioned. What if I just right click and look at the parameters here in Creo, you can see that it has actually done what it was supposed to do, and it's taken the native Creo part from Windchill, and you can see all the PTC and Windchill parameters in there. Now, if you don't use this, if you don't use this setting, or you don't have, or there isn't an equivalent native part in your MCAD library, then CoDesigner will actually create a 3D body itself when it places the part. Right. What we're going to do now is place this, position this component where we actually want it to be. So we're going to go back to our top level assembly, and we're going to add some constraints to this component in the normal way. So let's let's add a coincident constraint to stick it down onto the board. Then let's align those faces, and what I'm going to do now is I'm actually going to constrain it not to the board but to the enclosure. So let's add a distance constraint between this enclosure face and this component, and let's make that say 10 millimeters. There we go. This component is now fully constrained. What you will notice is the footprint hasn't actually moved with the component, but that's normal behavior, and we will fix that in just a moment. So what we're going to do now is add another component from our Windchill library within Creo. So we need to add that in the context of the board assembly. So we're going to add an RJ45 part. Okay, let's flip that and align these faces. Let's put it back by say 2 millimeters. And then for the third constraint, we will specify a distance between this component and the one next to it. Let's say we want those 5 millimeters apart, like that. So this component now is also fully constrained. Now I'm just going to show you another setting here, which is equivalent to the one I showed you before, but works in the opposite direction. So when you do a push from MCAD to ECAD, and this feature is recognize models placed in MCAD and use true electrical components in ECAD instead. Now, what this does is when the board is pushed into Altium, instead of just placing the 3D body that was placed in Creo, what it will actually do, it will look in the Altium managed workspace library. So let's see, we've got here this component RJ45 here, and if we look in the parameters, we've got one called comp ID, and that is set to C_RJ45. Comp ID is the name of the parameter we've specified for this function to work. So now if we look in the, sorry, one second, there we go. If we look in the properties for this part here, in the parameters, we see here comp ID C_RJ45. So what that will do is when I push the board through to Altium, it will place not just the 3D body, but the whole complete footprint, the native Altium part along with its footprint. So let's do that now. So I need to save this, and then I will open the CoDesigner board assembly. Here it is. You'll see that there's no footprint at the moment for this RJ45. There's no holes in the board. The pins just go straight through the board, but that footprint will be added in Altium. So let's do that. So we have finalized the location of J1, and we have placed the RJ45 post. Okay, that's gone through successfully. So go back to Altium, back to the CoDesigner panel, and we can see the push here. So let's have a look at those changes. And we can see J1 placement changed. If we click there, we'll see the change that was made in Creo, and RJ45 component new recognized. Now, recognized means that it has successfully found the corresponding native part in Altium. And if we highlight it, we can see where it's going to place that part. So let's apply those changes, and there they are. Now, what we're going to do is, obviously, because this J1 has moved, the footprint is now in the correct place, and we've got a footprint for the RJ45. So let's just push those back to Creo. Okay, that seems to have gone successfully. So if we go back to Creo, we can see that changed. So let's have a look at that and apply the changes. It just takes a couple of moments to create the new footprints. There we go. We've got the holes in the right places, and our footprint for J1 has moved into the right position. Okay, we're now going to go back to Altium, do a couple more things. These holes don't have any copper at the moment, so let's do that. So we'll select the holes. Let's give them, say, 4 millimeters of copper, 4mm pad, and specify them as plated. There we go, plated holes. And let's put a couple of tracks in. So there's one. Let's do another one from here. Let's drop a wire down. There we go, a couple of traces. And let's push that back to Creo. With a comment that we've added some traces and we've plated the hole. Now, what we're going to see when we go back to Creo is those traces we've just added are actually being generated as extruded features in the board assembly. So I'll just take a moment to create those. Now, if you had a complicated board with a lot of copper on it, enabling the option to create the copper as actual extruded features would mean that your board would take a long time to be generated. So this feature should only be enabled if you actually need to have the copper as actual parts for any sort of analysis, something like that. So you can see that there's an actual thickness to them. They're actually extruded features. If you choose not to have that option enabled, you do still see the copper, but it doesn't have an actual thickness. It's just a decal. So I'll just show you that. So I've just opened the board part on its own, and you can see the copper traces there, but they're just an image basically. So there we have it, the board inside its enclosure.